morning. Myself Parameswaran, Assistant Professor, Department of Biomedical Engineering, case of College of Engineering. This time I am going to handle electronic devices and circuits for second year Biomedical Engineering for third semester. In that the first unit PN junction diode. So PN junction diode is a semiconductor device. It allows only one direction in the current flow, and also it is used in rectifiers, that is signal detection, voltage regulation, switching in electronics, and also for protection circuits. These are the widely used in different types of applications of PN junction diode. In the formation of PN junction, this is the symbol of PN junction diode. Here the P-type has holes as a charge carriers. Here the N-type has electrons as a charge carriers. In that the depletion region forms, that we will see in the diagram. Here the anode is the P-type and cathode is the N-type. Here the anode act as a positive terminal. Here the cathode act as a negative terminal. So in the depletion region, there is no free carriers. It acts as a potential barrier. That is especially depends on the voltage. The PN junction diode material has silicon and germanium. For silicon, the conduction voltage starts from 0.7 volt. For germanium, it starts from 0.3 volt. This is the potential barrier of PN junction diode. The PN junction diode has two types of biasing, that is forward biased and reverse biased. The biasing is nothing but to give external DC voltage. Here the forward bias conducts current flow in only one direction. The reverse currents no current flow. This is the forward biasing circuit diagram. In that, here the P-type acts as a positive terminal and the N-type acts as a negative terminal. In this diagram, here the P-type of charge carriers, that is the holes, is moved towards the N region, and the N-type of charge carriers, that is the electron, moves towards the P region. In between that, the depletion layer is there, depletion region, that is in that the charge carriers moves in the opposite direction. At the time the voltages increases, the depletion layer decreases. So due to that, the conduction flow starts. Here the material used here as silicon material, so the conduction starts from 0.7 volt. That is, the current flows easily in only one direction. This is the reverse bias. There is no current flow because here the P-type of charge carriers is moved in the opposite direction. Here the N-type of charge carriers is moves in the opposite direction. At that time the depletion layer increases. Due to that, there is no current flow in the PN junction diode. That is, no current flow means that is very small current. This is the voltage current characteristics of PN junction diode. In that, the forward bias has sharp rise, the reverse bias has the small current. That is, if you take in the forward bias for silicon material, here the current conduction starts from 0.7 voltage. That is, here the knee voltage is there. In that, the current conduction starts from 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 volt. At the time only the current conduction starts, that is, the current increases. So here that point we can call it as cutoff voltage or knee voltage. For silicon material, the current conduction starts from 0.3 volt. That is, for germanium material, that is we can call it as cutoff voltage or knee voltage. In the breakdown region, here the Zener breakdown occur because of leakage current. That is, for silicon material 20 microamps, for German material 50 microamps. Here that breakdown we can call it as Zener breakdown or avalanche breakdown. Here the Zener breakdown is heavily doped region. The avalanche avalanche breakdown is lightly doped region. So that is heavily doped region means that is the voltage increases. Here the low voltage occurs in the avalanche breakdown, that is the lightly doped region breakdown, that is the Zener and avalanche breakdown. Here the applications used here are used in the rectifiers. In the rectifiers it is used to converting the AC voltage into pulsating DC voltage for voltage regulation, that is clipping and clamping circuits and also it is used for electronic circuits, signal detection and protection circuits. These are the applications of PN junction diode. Let's conclude the topic of PN junction diode. It is a basic electronic device. It is widely used in different applications of electronic circuits. Thank you.